No questions so far on any engines stuff that we talked about systems? Hey, Tegan. Hey, Jocelyn. Good, good. Tom Cunningham is coming in today, I hope anyway, on 10:30. So he's a A&P. He's actually retiring. He is a very successful aircraft maintenance business over there. But at the end of the month, he is retiring. But anyway, he said he would come in and talk to you guys a little bit about A&P, cleaner power plants, mechanics type stuff. A couple things. I thought that would dovetail well within going into the aircraft systems and then instrumentation. So next week we have Alyssa McGraw. She's an engineer from Sierra Space. They build these habitats that actually go into space. They're probably going to take the habitats that she's building or designing to Mars. They're not. But very fascinating what she's doing there. If you have a chance to go online for YouTube, if you look for Sierra Space, they did it's called they call it a destruction test. They inflate it. What it is, what they design, what she designs are these habitats that inflate in space.
I've seen those.
Have you?
Made out of like what? How was it, like Kelpa or something? Like it was like
like Kelpa. Yeah.
Like how carbon fiber is.
Yeah, exactly. 130. Yes. It's crazy. Was that what the maximum was? Yeah. They actually blew this one up, inflated it, and then they wanted to see how much pressure it could take. So they actually destroyed it. It's probably about the size of this room, the main room there. So it's pretty good size. She can tell you more, but it was fascinating to see when it exploded. It was just like boom. It's just like totally destroyed. So very fascinating stuff. Ethan, how you doing? All right, we got a few more minutes. So we also may have a newspaper from older day. We'll see. Anybody still interested in flying the Sims at all? Yeah. Okay. Okay. Yeah. Okay. So if you guys do want to fly the Sims, definitely reach out to me because we have to get it on the schedule so we can get in there. So we had a group from Wanakee come in this week. It's about 10 students, and they used them. They used both, or actually all three Sims that we have over there. So I'm hoping when we actually take the class over there, we'll have enough, enough instructors. But if not, I'll show you guys how to fly them. Probably get everybody used to that's fine. And then, like I said, you can schedule off hours as well. It doesn't have to be side plans. And then someday, I'll be over here with the twins. So my twin is just getting out of annual inspection, so I was thinking of later over a day. There's still some that they've got to finish up on it. So that happens.
Let me see something.
The twin Comanche actually does have 6 seats. The 2 far back seats are really small. They're for basically very small people. Kids. I removed them and I just use it as a 4-passenger. It's also insurance. It is designed to take 6 people. a lot, what you're finding a lot in aviation is a lot of the planes that have 6 seats or 8 seats or something like that. They're somewhat restricted by how much fuel you can put on board. You can't do full tanks and then load off all the people in the plane. They can't, throw all the baggage and all that stuff. I think you have to be really careful. Jason and I were just talking about weight and balance. So that's something we're going to talk about. And you'll see it there when we do weight and balance. Because if you load it incorrectly or if it's overloaded, the plane may not even get off the ground. So, or worse yet, it'll just get off the ground and just stay ground effect. It'll just hover. So, all right. Well, let's see. I think we'll go ahead and get started. So we're on 7-17 in our books. I think last time we talked about oil and some of its effects. Great. So if you look at oil systems, so oil, I think we mentioned this last week. Oil does several things as far as helping the engine perform better. Big thing is obviously lubrication, but it also cools the engine. It helps distribute oil from bearings, or it distributes heat. That is, it takes heat off of bearings and any surfaces where there could be friction. And it draws that and impurities away. It'll take that stuff away and move it into what's called a low pressure oil screen. This is typically something you can remove from the engine. It's normally located on the bottom of the crankcase. So like here, this engine right here is right here. So the oil screen's probably going to be the low pressure oil screen that comes down here someplace. And that's just oil as it passes, as it drips down. It goes through that. That screen does a couple things. It filters out any kind of metal shavings, particles that get stuck in the oil. We'll kind of drop in there. That's not its main purpose. It does assist with that a little bit. The other thing that it does, when a mechanic comes in and inspects that, they look at that screen to see if there's any kind of metal shavings in there, because that would indicate that there's something going on in the engine. Like the metal is rubbing against something it shouldn't, and it's starting to chip away at itself. So, and then there's also what's called a high pressure. This is typically where you have a high pressure screen. So this is, you can see it goes right to the filter right there. So what this does is it filters out a lot of the fine materials, so fine that you typically can't see them with the naked eye. You have to get the magnet or something like that to move the particles. But when they inspect engines, they will actually use a magnet and they collect I'll tell you the process. So what you do is you take your oil filter off, you cut the oil filter open. This is like whenever you change your oil, you have to do this in most air-cooled engines. Take that oil filter can off, and then you open up inside there. Have you guys ever seen the inside of an oil filter at all? It's just basically, it's just paper. It's like a very thick paper. And you cut that paper out, it folds out like this, and then you can write either a magnet over it, or you can clean it out, which we're looking for little black specks. And if you have, they'd say about maybe as much as like just a tip of your pinky finger. If you see that much, that's pretty serious for an engine. If you have a lot of metal shavings, and that, like I said, that usually means that there's something happening in the engine. Now, you can actually send your oil out for analysis, and they will analyze the types of metals, the wear metals that you have in the oil. And they can tell you, okay, well, this is a bearing that's starting to wear. Or, because all these different components inside the engine, they're not all made of the same metals. They're made of somewhat different metals. And they can tell you, whether it's a ring that's starting to fail or whatever it is, just by the composition of the metal itself. Obviously, we have an oil pump, and that's to get that oil through the system, keep it moving through the system. Without the engine or the oil moving, it's not going to do you much good. It might lubricate, but it's not going to draw away the heat and the contaminants in there. Let's see, typical stuff. Yeah, the dipstick we're all familiar with in the car. It's the same thing there on the over oil pressure relief valve. If there's too much pressure, it's going to put that there. So, but yeah, the main components are that the main screen, the pressure screen, filter, and the pump. That pump is going to blow it through like little galleries in the end of the crankcase, so that everything that needs to get around gets it. Another thing that oil does is it helps to prevent corrosion. So, after you get done flying, that oil is kind of splashed out all over the place, and that helps keep the water from getting into the metal. So oil is super important. That's why when we do pre-flight checks, that's one of our primary things. There's a lot of things you might be able to skip, which is not a good idea. But if the one thing you don't ever want to skip is the oil. You always have to check to make sure. But if you had to jump in a plane in this emergency, the first thing you would do is check. Okay, so other types of cooling systems. So oil cools the engine, but also we have open cowlings and stuff like that. So this right here is a cross section of an aircraft. In the front of this, you've got openings on either side of the prop there, and we can see here oil or air flowing through. I think we talked about this a little bit last week as well. But it's how the air flows through that engine is very critical. The engineers, when they design these cowlings, they design them very, very tight specs to get that proper airflow across the cylinders. And I think you've seen like the flows in and around the cylinders, drawing the heat away. And this right here is what's called a cowl flap. All this is just a little opening. So if you look at the bottom of the cowling on some higher performance aircraft, they'll have like a little door that opens up. And usually when they're on the ground, that door is open, primarily because when you're on the ground, you're not getting as much cooling effect from the air. So they open that up and it allows lots of air to flow through there. So Cessna 182 is a classic example of that. If you've ever seen it's like a 872, but it has a beefier engine, and because of that, they have these open cowl flaps that draw more or allow more air to flow through there. So engine cooling systems. Then obviously we've got water cooled engines, which we don't see generally much in smaller aircraft here. So. Okay, does anybody remember the 4 strokes of a 4-stroke engine?
Okay.
Okay, that's the first one.
Power stroke.
Exhaust, yeah, okay. Those sometimes can be hard to remember, but just remember, like when you breathe, the first thing you do in your 4-stroke engine, you're literally like a human 4-stroke engine. You're inhaling, that's the intake, and then you're compressing, but you're generating power with your lungs, and then you're exhausting it. So you've got 2 of the 4 strokes there. You're inhaling and exhaling. The power strokes are in our lungs, and we come from the way we're made up, all made up. So the 4-stroke engine actually, you can actually consider the a jet engine a 4-stroke engine. It actually has the same principles. It has intake, compression, combustion, and exhaust. It works the exact same way, except that it's a linear flow. It goes straight across, whereas in a reciprocating engine, it's back and forth because the piston's there. So, okay, and then starting systems is on 718. Most aircraft have a starter, an electric starter. Notice I use the word electric. So the starter itself is driven by a DC, typically a DC current, like from a battery or something like that. It's just going to throw a little crank into the gear here on the crankshaft. And it's going to spin that, and it's going to cause the airplane to turn over, and eventually it'll start because you've got spark and everything. generating there. So let's go here. Yeah, so this is a, don't worry about this diagram, looks really complicated. It's actually, you don't have to worry about it for the test. You just need to know that, if your plane is equipped with an electrical system and it has a starter, then, you're going to have a starter switch, obviously. And it's going to, this starter right here engages into the engine and gets the engine to spin, turn over when you turn it to start. Now, this is curious right here. Does anybody know what all these little symbols right here mean?
Left,
Magneto.
magneto,
Okay,
yes.
yeah.
It's the left magneto, right magneto, and both.
Both, yeah, exactly. And then the S?
It starts.
Start, yeah, okay. So how this works is, for the first thing to do when you get in the plane, you're going to, actually, after you do your pre-flight inspection and test everything out and you're ready to start, you'll get all clear prop. You'll hit your alternator or your battery button. And sometimes your alternator at the same time there, but usually at least your battery. That ties the battery into the system. So now this is live with your battery button there. And then you'll turn this key switch right here. And sometimes it's just a push button switch. It's not always a key that you insert into the panel there. But you'll turn it past the left, right, both, and then it just springs back to both. So you crank it, you hit it to turn it to start. The engine will start to crank. And then once the engine is started, you just let go of the switch and it falls back to both magnetos. So again, off means that the magnetos are off, left magneto, right magneto, both magnetos. And I think we talked about magnetos. So you guys, I'm sure you guys remember this here. Here it is. So remember we talked about these magnetos, the left magneto, right magneto. So these are actually attached to the engine, the magnetos, and they actually are driven by the crank shaft on the engine or gear from the crankshaft on the engine. So when that engine is rotating, these magnetos are generating the spark or the power to cause the spark plugs to fire. So as long as this engine is turning, these are going to be producing power. And that's how we get our spark plugs. And that's why when you turn your battery off in a plane that's flying, it doesn't just quit, because it's getting the sparks from the magnetos, which is they're engine driven. They generate that high voltage to get the spark to jump across that gap, which ignites the fuel air charge. All right. So you'll see they've got even more complicated diagrams of it here, but this is basically pretty simple. You've got a switch that goes to, this is like a powered switch right here from the battery. When you click on that battery switch, it connects these two, then powers the system, the main bus right here. And then from there, you've got a push button starter right here. Press that, or actually this right here drives it. It's essentially these are right here like relays that cause power to go through there. They don't actually run all that starter power through a single switch because there's so much current. They actually run it through something like that. Let's see here. Yeah, a lot of aircraft do have an external power plug to jumpstart it. You need to jumpstart it, so you just plug that in and go from there. So. Okay, let's see. So they do talk a little bit about two types of scenarios here. Well, they talk about the combustion process. There's a couple things that can happen with combustion. It's kind of curious, but so normal combustion, when the two spark plugs they ignite the fuel air charge, that there's a wave front that pushes out and generates pressure against the piston and pushes the piston back. So it's a nice smooth flow. A lot of times, at least this is what I thought before I learned about this. I always thought that it was just an explosion in the cylinder that blew the piston back. It's not the case at all. As a matter of fact, you don't want that because it's very hard on the engine. So normal combustion is like somebody pushing, on that piston, pushing it down and getting it to rotate the crankshaft there. So this would be a normal combustion. Explosion, or sometimes what's called detonation or preignition. And those are two terms you're going to have to know for the test, by the way. I won't get into that in a second here, but that's when something happens, something goes wrong. There's too much pressure, and the fuel air charge explodes. It can damage an engine in some cases in as few as 10, 15 seconds. You get a lot of that. So detonation is a really bad thing for an engine. Normal combustion, obviously, it's what the engines run on. So I think we do talk about that here. Let's take a look here. Yeah. Okay. So this is on 719. So the detonation, they describe it here. Detonation is characterized by high cylinder head temperatures, and it's most likely to occur operating at high power. So you've got your throttle firewall are all the way forward. You're generating lots of power. That's when you're going to have those high pressures, and again, it's very destructive to a cylinder. Usually, you'll see it or even hear it in the engine if it's going on. Now, there are two types of things that are abnormal combustion. So you've got detonation, and you also have what's called pre-ignition. So in the difference between this is something, again, you're going to want to know for the test because I'm pretty sure they ask about this. Pre-ignition, well, let's talk about normal ignition. When the magnetos come around, they generate a spark. Here, it ignites the fuel air charge. This builds pressure and pushes that cylinder or the piston down. In pre-ignition, what's happening is typically there's like a little hot particle somewhere in the cylinder. Maybe you've been running the engine really hot, and there's a little piece of carbon that's burning. So the problem with pre-ignition is, well, what happens in pre-ignition is as the fuel air charge comes in there, it hits that hot particle that's bright white hot, right? It's burning away. And instead of waiting for the spark plugs to ignite it, it ignites on its own. The problem with that is if the way that the piston works, it's coming up and down. If the piston is coming up and the fuel air charge ignites before it comes all the way up, it can try to push it back down. That's like fighting the engine, and you get these horrible vibrations in the engine. If you've ever had it, I've never had it happen to me, but it can literally destroy a cylinder in a matter of seconds. So it's one of those things that you want to be careful with. Again, it's only going to happen. Most of the time, it's only going to happen when the engine is running it at high power. You're not cooling it. It's running too lean. When I say lean, you've got too much air and not enough fuel being mixed in to the fuel air charge. So that's the difference. So detonation is when the fuel air charge combusts at the normal time with the spark plugs, but it's too high of a pressure, and it causes some damage to the cylinder and the piston. Whereas pre-ignition is literally that the fuel air charge is igniting before the spark plugs go off, and because like this fist right here is the cylinder or the piston is coming up in the cylinder like that. If here's the top cylinder, as the piston comes up like this, if the little hot spot there ignites the fuel air charge before this reaches top, it's going to try to push it back down, and that's when you start breaking linkages and destroying engines. They will survive in some cases, but usually there's going to be some damage to it. So that's the difference between pre-ignition and detonation. And again, you're probably going to see that on the test, just so you know. And again, it's not something you're probably ever going to see as long as you maintain your power settings correctly and you understand that the engine is what it's doing, keep it cool, it should work fine. So we're not going to get into a lot of the turbine stuff because there's no test questions that I'm aware of on the FAA test. But so there are a couple terms that you need to be aware of. So FADEC, that FA, this is on page 7-20. FADEC stands for Full Authority Digital Engine Control. So in the old days, we had, you have your throttle, and you have your mixture control. With all the new computer technology and everything that was introduced in the 70s, a lot of these systems now can be managed by a computer. So what we had to do before was we had to manually adjust our mixture in flight, adjust the throttle to give us the proper amount of power for whatever condition. Now with FADEC, it's just a single lever. Now we talked a little bit about variable pitch props. That was another control that you'd have to manage. If you had a high performance aircraft, you'd have to adjust that as well. So that's 3 controls that you'd have to adjust prior to FADEC. A lot of the new aircraft, that's all they are. They're just FADEC controls. It's just a single lever. If you want to go fast, push it forward. If you want to slow down, you pull it back, and then the computer figures out what the prop angle should be, and then also what the mixture should be, and it does everything for you. So that's the big thing with FADEC. It handles a lot of the stuff that we had to do before in our minds. When we went through things, adjusted power settings, we'd have to do that. A lot of the older aircraft, typically the ones you're going to fly initially anyway, are going to be the old style engines. You're going to have to adjust your carburetor heat if you have it, the mixture control, and then obviously the throttle. But in the FADEC, it's just one lever. It does everything. And they're remarkable. So a good example of a FADEC controlled system would be like a Cirrus SR22, SR20s. Those have FADEC controls on them. And it takes a lot of the work out of off the pilot, and all they have to do is they need to go push forward, pull back to slow it down. So, all right. So there's several different types of turbine engines. So there's a turbojet, turboprop, turbofan, and turboshaft. They all have distinct purposes for their designs. So a turbojet engine, let's start with what they have in common. So they all have that same 4-stroke process. Okay, they have the intake, they have compression, they have the combustion, and then they have the exhaust. Every single jet engine and 4-stroke engine that we have in general aviation has the same 4 things and actually even in the 2-stroke, you still have those same 4 things that are happening. But let's talk about the differences between them. So a turbojet engine is typically going to be so this right here is a turbojet, and notice how narrow this is. It's a very narrow engine. There's no fan blades sticking out here at all. They're very compact. So here's your intake right here. This is the intake process. This is your compression area. This is where the air gets compressed. This is a combustion area. The gases expand and they go through the exhaust. This turbine right here helps drive the engine. As those exhaust gases pass through that, they spin this, and it causes this whole shaft to spin here. And there may be some gear reduction there or an increase. But regardless, you've got expansion through the combustion chamber right here, and then it blows out through the exhaust. But notice how small or actually narrow this whole engine is. It's very small. Whereas if you go to a turbofan or a turbofan. So this is a turbofan engine. Notice you've got a huge fan out in front. So a turbofan is you still have the same 4 processes. You have intake, you have compression, you have combustion, and exhaust. But the big difference here is you've got this big, huge fan that bypasses the inner part of the turbojet engine. And this actually is designed to produce thrust, but it produces it outside of the engine itself. That's why in like a lot of the jets you see nowadays are turbofans when you fly in commercial flights. They've got big, huge openings, whereas in the old days, the 50s and 60s, those were all turbojets, and they found that they were very inefficient. With the turbofans, you actually get much more efficiency when you suck in some of the air and then blow it out outside of the engine housing. So that's the difference between a turbojet and a turbofan. A turboprop, very similar to a turbofan engine. The only difference is you've got a gear reduction box on the shaft right here, and then you have a prop in the front. So it's like a you're converting, instead of the turbofan, you have this gearbox that drives a prop itself. So good examples of that would be like the King Air series aircraft. They have turbo props, and you can always hear a turboprop. They sound like a jet engine when they first start out. You'll hear that like whining. It'll get higher and higher, and then the prop will start spinning. That's a turboprop engine as opposed to a piston engine. So when you start a piston engine up, the prop is just instantly going to start spinning, and there's no whining at all or anything like that. So a turbo shaft here. So a turbo shaft engine. These are typically used to drive something in the aircraft. So yeah, if you're familiar with the term APU, that stands for auxiliary power unit, those are used in big aircraft to help power the system. So a turbo shaft engine, this right here, it's not producing any thrust. Notice how the exhaust is points straight out like that. That's because all of the power is absorbed in this shaft itself. This typically will drive like a generator, or it could drive rotor blades on a helicopter or something like that. But the whole idea with a turbo shaft engine is that you're taking the power and delivering it to someplace else in the plane. So commercial airlines, when you fly on those, the first thing you hear when you get on the plane is the pilots are typically going to start the auxiliary power unit, which is a small jet engine. It's a small turbo shaft engine, and it's just it'll go on for a little while, but that's going to drive the generator so they can power up their avionics and get all the systems running. They do have some battery power on it, but it doesn't last long on most commercial jets. They usually have auxiliary. So the four different types there, those are the primary ones. And again, you've got your turbojet engine, which you don't see very much anymore, turbofan, turboprop, and then the turboshaft. That's a distinction between those. Any questions on any of that stuff? They do talk about some of the instrumentation on it. Again, it's not something you're going to see on the FAA private pilot test. I think that's at least not that I know. I don't think there's anybody that's going to be doing a private pilot test in a jet. They may have to get a rating for one later on, but typically you're not going to see that. So there are some instruments that we do use turbo engines or turbine engines. 7-22, they talk about engine pressure ratio. Again, I'm not going to go into this because honestly, you're just not going to see this. But the two common ones are going to be your N1 and N2 indicators. Those are going to be, that just helps the pilot identify how much power the turbine is actually producing there, how much pressure is in there, and things like that. So, but again, if you want to, you can kind of read through that. I'm not so concerned about it for the test itself. Object, yeah. You might hear the term FOD. That kind of affects piston aircraft as well. Foreign object debris, that could be a nail, it could be a bolt or something like that on the runway. Reciprocating engine, general aviation engine, it's really not as critical. But for a jet engine, if you get a bolt or a nut that gets sucked into the intake, that can do some serious damage to it. So, all right. So on page 7-25, airframe systems. Yeah, they talk about fuel systems. So there's several different types of fuel systems in general aviation aircraft. So you've got two different types of aircraft. You've got like the Piper's low wing aircraft. That's what this is right here. You've got the high wing aircraft, like the Cessnas and things like that. So Cessnas, because they store the fuel in the typically in the wings, you've got two tanks, one right here and one right here in the wings. Because of that, and the engine, let's say, is down here, we can see it below the tops of those wings. So they fill the tanks up here. These are what we call gravity fed in most cases. Like all the 172s, most of the 172s, that is, I have a tank up here, and they'll just do gravity feed. They'll just allow gravity to flow down from here. lot of the newer Cessnas, I think after was it 70 something, they put in boost pumps, auxiliary boost pumps in there just in case the gravity wasn't enough to get the fuel down to the engine. But in most high wing, especially the older high wing aircraft, it's just gravity fed. There's no boost pumps or anything like that. It just flows down into the system, into the engine, and then you get started there. A low wing aircraft, however, well, now you've got your wings and your fuel tanks below the engine. So you need some way to get that fuel up into the engine in order for it to work. So we have, you have electrical boost pumps. They're exactly that. They run off of electrical. And does anybody, well, there's the other type of fuel pump would be an engine driven fuel pump. Does anybody know why we would have electrical and engine driven fuel?
You'd get the electrical because if the engine wouldn't start, because it's already, you would have to have an electrical one to get fuel to the
Exactly.
engine.
Yeah.
Yeah, to start.
Yeah. Yeah. So there's other reasons. Can anybody think of any other reasons why you would have? What's that? Yeah, redundancy and backups. Yeah, absolutely. You need to have those because what can happen with engine, it doesn't happen very often, but you can lose your engine-driven fuel pump. And if that happens when you're in the air, obviously that's a problem. So if you've got your electrical fuel pump, you just turn that on and the plane keeps flying. And then obviously you have to land someplace and get that electrical or the engine-driven fuel pump taken care of. So the engine-driven fuel pump is exactly that. It's driven by the engine. It pumps fuel into the engine while the engine's spinning. Whereas the electrical fuel pump is going to run when you turn it on and you have power to it. So if your battery's dead, you don't have any power, your alternator's dead or whatever, your electrical fuel pump's not going to work. You have to get rid of those things that in flight. So any case, so that's the difference between the different types of fuel pumps. The other thing that fuel pump will do is it also help with priming. Normally, most aircraft you'll have what's called a primer. In the old days, you guys are, maybe your grandparents might remember this, but in the old days they had to prime the engine. So what that means is they would basically squirt some gas into the cylinders to get the fuel in the cylinders to get it to start. Have you guys ever worked on engines and you had to start it up engine and use like spray starter?
Yeah, we have a snowblower and you have to press the pump.
Yeah, it's like a little rubber
to start it up.
Yeah. So they still have. Yeah, that's right. I forgot about that. Yeah, a lot of the weed eaters and things like that. There's like a little, what's that? Yeah, leaf blowers. Yeah. So that's the same concept that you're doing there in the engines. You're going to have a primer. And this is a curious little story. In World War II, there was a fighter pilot that had lost his electric pumps, his engine-driven fuel pumps, and I think he was coming across the channel, and obviously he had to land on land. And what he found out was that he could use the primer to keep fuel going to the engines. So he just had to time it right, and he kept fuel going to the engines with just the primer. So if you ever get stuck in a situation where the fuel pumps are both dead, which would be extremely unlikely, you can use your primer to keep pumping fuel into the engine. And it's not good for the engine, but it'll get you down if you needed to do it. I think he did it for like 15, 20 minutes. He kept on pumping it and was able to land it safely. So, and that illustrates to me what pilots that really know the systems of the aircraft can do. You guys are learning all this stuff, and someday you're going to use it. Hopefully you will never get stuck in a situation where you won't, or where you need to figure out how to solve a problem. But if you do, you have the basic skills for it. And if you know how those systems work, you can solve problems in the air like that. That's what we cover so much in here. Probably go into in-depth a little bit more than what I should, but you never know. Maybe there's some story that'll you'll remember, and it might help you in something. So, all right. Let's see here. Okay. So this is just a diagram of a gravity fed system. So again, this is going to be like the high wing aircraft. You've got the fuel tanks that are in the wings at the top here. You've got a fuel selector valve that's in the cockpit. Typically, between the pilot and co-pilot, you're going to stick a little, it's just a little lever there. And then you have, this would be like probably a fuel screen or something like that. So primer, this goes to the primer, then this goes to the carburetor. And then this system right here, because the fuel tanks are lower than the carburetor, the fuel has to go through a pump right here, or engine-driven pump, and electrical pump, and it's going to pull the fuel into the carburetor. So, all right, pretty straightforward. This is another diagram, basically the same thing. You've got fuel, you've got screens in there, fuel shutoff valve. You'll see that a lot in the Cessnas. Actually, a lot of aircraft will have some sort of fuel shutoff valve, and that's normally when you land, you'll shut the fuel off because you don't want something leaking in the aircraft. Sometimes it does leak, but it'll go through there, go through a strainer, and then so, okay. There are several different grades of fuel. And some aircraft can only burn certain types of fuel. So when you're fueling up an aircraft, obviously you don't want to put in like car gas or something like that. If not, there are some aircraft that will allow you to run, we call it MOGAS in the aviation industry, which is just car gas. They do have what's called a STC, which stands for Supplemental Type Certificate, that allows that aircraft to burn auto gas or MOGAS. Most pilots are going to want to fly with aviation fuel. It's very expensive. It's typically on the order of at least twice as expensive as car gas. So if you pay $3 for auto fuel, you're going to pay $6 for aviation fuel. But they're designed to run on air-cooled engines, and the way the engines are designed, that there's all these different things that are different than an automobile engine that's water cooled. And so they take all this stuff into account and they create this blend of aviation fuel. So there's several different types of fuels. So you've got the most common one is going to be this 100 LL, which stands for 100 low lead. It's not no lead, it has some lead in it. Back in the old days, in the 70s, 60s, 50s, lead had, or car fuel had lead in it. And the reason they did that was because the lead actually helps lubricate, some of the components in the engine. Now, it also does some other things in there, but what they found, though, is that lead was extremely toxic. And there's a term for it, I can never remember the name of it. It's a special chemical they put in there, and it's very bad. The federal government said we can't have this stuff. People driving cars around with this lead in it, so they banned lead from automobiles. I think that was in the 70s, and then aircraft, because they rely on lead, they had to formulate a new one called this 100 low lead. Originally, it was just 100. I think they had 80, 89, 90, and 92 something at one point. But now everything is pretty much just 100 low lead for federal aviation. Recently, they've come up with the unleaded avgas, and they're just testing it out right now. I've heard a lot of really good things. The FAA has done a bunch of tests on it. GAMI, I think, has their advisory group, if you will, I guess, to the aviation industry. They've done a lot of testing on it, and it looks like they'll be able to use this unleaded gas. Here we are, it's 2024, and it's taken this long for aviation fuel to become unleaded. So we've been all these years up until this point, and I still burn 100 low lead in my plane until they make it available at the airport. But it's the reason it's taken so long is because they don't want pilots to have problems with the planes. When you change fuel, it seems like, okay, well, I should be able to put automobile fuel in my plane, it'll run just fine. And it may run fine for, a couple of years, and then all of a sudden you start having problems, and all of a sudden catastrophic failure. That's what the FAA is trying to avoid when they create new fuel formulations. And this one right here has been out there for a number of years. They've tried it on several different fleets. And this unleaded now it looks like it's starting to gain some traction. And I think probably in the next couple of years, you'll probably start seeing airports that run it. I think SOC actually and Portage actually have a no lead fuel that they sell there. So, but the vast majority of airports still have the full.
Is the chemical called
Tetra. Yeah.
lead.
Yeah. 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 It's very nasty stuff. I mean, you don't, when you get under low lead, if you get it on your hands, you want to get it off as quickly as possible. Because it does some really horrible things to your central nervous system. So, and that's if you had the pure chemical, it would probably kill you. If you get 100 low lead, I've spilled 100 low lead on my hands before. And they're still there, I guess. But yeah, so there's, it's something you if you're around it a lot, you just want to make sure that, you use gloves or things like that. You just don't want to have it come in contact with your skin. It's not the end of the world if it does, but that chemical that's in it is extremely nasty stuff. That'll be really bad. So, all right. So again, fuel colors, fuel grades. So there's avgas, which is 80, which we don't see anymore. This is on page 727. Yeah, here we go. So these are the different fuel colors right here. We don't see the 80 avgas anymore. The 100 low lead or the 100 avgas. I don't know if that's leaded. That might be full leaded. Yeah, these two might be fully leaded fuels. And then the 100 low lead, that's the one we're going to see. But notice how they all have different colors. This one has kind of a red color to it. When you hold it up to the light, what you're going to show you here. So this is a it's basically it's like a test tube. It's got like a little wire in it. Jace, you've seen it before where you do your pre-flights.
Isn't it like on a highway? Isn't it just like more like a strap? Like I've done a pre-flight where.
Oh yeah, you can. That's another type of way of checking it. So it's like it's a transparent straw you stick into the fuel tank. You put your finger over it, and then with suction it draws it out. Then you can look at the color of the fuel.
That's what I see.
Yeah. So those actually measure how much fuel you have in the tank. This right here is draining the fuel out. This is on the bottom of the fuel tank right here. There's like a little. It looks like a nut, and then in the center of the nut there's a little hole. What you do is you take this little device right here. It's just like a beaker with a little wire on it, and you stick it up into that hole and you push it up in there, and it drains fuel down into this test tube. And then you can actually inspect to see for a couple things. Number one, the color of the fuel. It should be light blue. What's that?
Like you have water.
Absolutely. So I'm glad you brought that up because with aviation fuel, it's very light compared to water. So because of that, if there's any water contaminant that's sitting at the bottom of the tank itself, so like, where this drain is, it's going to be like, somewhere probably back here, you'll see it. There's like a little hole there. If you ever look at a high wing aircraft, you'll see it, about that point right there. And again, on this side, same thing, same place. You're going to have one on this tank as well. That's the lowest point of the tank itself. What you'll do is you'll take this little thing, you'll stick it up in there, and it draws the fuel just kind of leaks down into the little tube there. You hold it up to the light, but because it's the lowest point in the tank, if there's anything that's heavy in the tank, that's going to go to the lowest point. And when you put that little test tube up there, the fuel tester there, and you fill it up, if there's any water in there, it'll get drawn into the test tube itself. And what you're going to see here is little tiny bubbles on the bottom of the fuel tester there. You're going to actually see little bubbles. If you see anything like that, you want to drain more fuel to make sure that there isn't more contamination, because obviously water doesn't burn. And if you send it through the engine, if there's enough of it, the engine will just quit. So we look for any differences, and again, it's very distinctive. It's the fuel itself does not mix with water. It's like oil and water. It's the same thing with the fuel and water. You'll see these little tiny white clear bubbles on the bottom of it. So again, we're looking for, number one, the color of the fuel. 100 low lead is that blue color, kind of a blue tint. You're also looking for contaminants like water bubbles. I've heard of guys draining out their engines after a bad storm, and getting nothing but water. So they don't see any blue or anything like that. So you always want to make sure that you check the color. Yes, James.
Have you ever had water?
I have. Yeah. It's never caused me problems because what I typically do when I see that, I'll actually drain out quite a bit more fuel just to make sure I draw everything out, and then I'll run the engines up just like I would normally to make sure that there are issues with it. You would notice like shutters, if there's small amounts of water in, you make it shutters. Another thing that I do oftentimes, well before I actually do the pre-flight, I'll just rock the wings like this. I'll just come over here, grab a wing and rock it like that. What that does is it splashes the water up inside the tanks there. It splashes it and it picks up some of the condensation, water condensation that forms in the inside of the tanks there. And then that stuff will just over a period of a couple of minutes will start draining down into the low spot of the thing. So that's something you want to consider doing. When do you think? So obviously a rainstorm can be bad if your fuel caps don't have good gasket seals. Is there anything else that could happen on a hot, humid day with engines? Is there anything that we have to worry about inside the? What's that? Humidity. Yeah, humidity is definitely, if it gets in there. What else? So you've got these tanks inside the wings here, right? And if the tanks are low, let's say you only have a couple gallons of fuel in it, the person that flew it before you didn't fill it up. What can happen is dew can form on the insides of the tanks. If there's any moisture or anything like that in the air, it can condense on the inside of the tanks. That's why I always rock the wings. I walk up to the plane and grab the tip bit and rock it like that. It splashes the fuel up and it washes that dew that's inside the tanks down to the bottom. And then you can check give it a couple minutes for the water to settle. But then if you go again and drain the fuel tanks, the sumps there, you'll actually see the water in there. But yeah, so if you're going to fly and the tanks are low and the plane's been sitting out outside, that's a good recipe to have some possible water in the tanks. There's another reason why I rock the wings periodically, and that's because most tanks on new aircraft, they just use the walls of the aluminum. I mean, basically, it's just the surface of the wing itself as a tank itself. But a lot of older aircraft, including the one that I have, just one of them, has this use what's called like a rubber bladder. And rubber bladders actually, over time they can crack. And what they recommend is that you keep splashing fuel up on the sides of it. It keeps it hydrated, and the tanks last a little longer training.
So involving rubber bladders, they're mainly used in a lot of the different warbirds in general. Because they would rubber, or so if you had something, if I had a stray bullet go through it, would just rubber how it actually is, which is resealed.
Yes, yeah, they call them self-sealing fuel tanks, and the B-17s greatly benefited from the self-healing fuel tanks. Yes.
So how would they crack?
Well, the thing is, if you let a piece of rubber sit for a long period of time, they can develop cracks in them. Rubber dries out. It needs some sort of moisture in it, and whether it's fuel that's the moisture or something else, but typically you want to keep it moist with fuel. So and all you're doing when you rock the wings, you're just splashing that fuel around there. It keeps that rubber so that at least there's some fuel on it, and it helps prevent it from just drying out and cracking. That's what I'm going here. So a couple of reasons why you'd have to, if you bought a plane, let's say, and you wanted to take really good care of it, you'd want to find out things like that. Does it use bladders, rubber bladders? If so, then you want to make sure that they're set. What you'll see in the plane is you'll see weeping from the edges of the wings. If your fuel tanks are leaking, you'll see little blue stains that kind of flow backwards on the wings, right? Usually right here. You'll see little stains from the color of the fuel, in this case 100 mil lead for these smaller ones there. So all right, so fuel contamination. So again, water. Also, you're looking for debris in there. Sometimes fueling systems can, let's say if somebody just fueled up your plane and all of a sudden you see a fuel truck pull up, that means that you were basically getting the last of the fuel that they were using, which means probably going to be sucking in a lot of that, when you fuel from a main tank, there's always that possibility you're going to get some of the sediment on the bottom of the tank. They've got filters on these fuel systems, but it's not always a guarantee that the fuel that gets into your plane is going to be contaminant free. So, if they just filled up the tanks, you're probably the main fuel tanks, I should say, not in the plane, but the fueling station there, you're probably going to be all right. But if they run them dry, then you have to be really careful because you could get some serious contaminants in there. Okay. Any questions on that at all? Right. This is 728 fuel system icing. Again, not something you really have to worry about with general aviation. You can, the only time you're going to have ice, you need to have something that can freeze to turn to ice, and like water. Obviously, if you get a lot of water in a system, that potentially could freeze. Water has to get in the fuel system in order to freeze though.
This is almost like how what happens to carburetors, like carburetor icing.
This is different. Good observation. So with a
sometimes like the icing systems, like maybe Cirrus.
yeah, Cirrus has got what's called a weaving wing, and that's what we can talk about that in a second. This is actually fuel system icing that we're talking about here. So with fuel system icing, it's usually a result of getting water in the fuel tanks, and you've got a combination of that and really cold weather. What will happen is when the water gets down into the fuel selector valve, where the valves are, that's where it's going to freeze up, and that can spell disaster if it happens in flight. Generally, it's not a problem because you have tested the fuel to make sure there's no water in it, and as long as there's no water in it, then you should be good to go with it. But it is something that you have to be aware of when the conditions get really cold on there. So let's see. Yeah, they've got. I mean, if you fly in really, really cold weather, the fuel can actually gel up. It would have to be super cold, and I don't think anybody would. And again, I don't think that it's even the FAA's even talks about that in the test there. But that is possible for fuel gel. It's more of a problem with kerosene or jet fuel. Refueling procedures, again, just common sense stuff. Whenever you're refueling an aircraft, you always want to ground it. So whenever you pull up to a fueling station at an airport, they have a grounding cable that you pull out of the fueling station, and you attach that to some piece of metal on the plane itself. That's going to discharge any static that may have built up on the plane itself. And then from there, you can go ahead and connect the fuel up, turn it on the power and fuel up your. So again, on page 729, they talk about fuel fired heaters. On my twin, I've got what's called a janitrol heater. It's about the size of a coffee can. It's just a little tiny furnace. And why would I have to have a separate furnace on a twin when I've got two engines producing all that power? Why do I have to have? What do you think?
Because if you have a cold discharge, you're just not using it for a while, you're obviously not going to be able to get that power up if it's cold out. So you want to have a different source.
Method. Yes. Okay. So actually, what I'm looking for with a twin engine, you have the engines outboard. So like in a regular engine, like in a regular aircraft like this, you've got a single engine, right? The engine's right in front of the cockpit, right there. It's right here. And we could actually draw heat off the exhaust manifold and pipe it into the cockpit. On a twin engine, you've got the engines on the outboard sides of these wings here on the mid portion of the wings there. And there's no effective way of routing the heat from the engines into the cockpit. So that's why we have a small heater, this Janitrol heater. I think there's another company that makes them as well, but Janitrol is probably the most common one. And it looks like it's just a coffee can, and it just sprays in fuel, and that creates a heat in there when they ignite it, and that blows it into the cockpit. So that's one type of heating system. The most common type of heating system in an aircraft, again, is that exhaust. You're basically tapping into the exhaust of the plane, the heat from the exhaust, and you're piping that into the aircraft. Now, there's some potential problems with that. You may guess what that might be.
Inspiring. Impossible.
What was that? Did somebody say
Exhaust.
exhaust? What's that? Yeah, exhaust going to the cockpit. What's
Carbon
exhaust?
monoxide.
Yeah, carbon monoxide. Yeah. So carbon monoxide is a byproduct of the combustion process, right? And obviously, carbon monoxide is toxic to humans. What happens in a single engine where you're just drawing heat to drive the cabin is there's what's called a shroud that wraps around the exhaust manifold, that exhaust pipe that comes off the engine, right? So that gets really hot. Aircraft engine exhaust is very hot, like 1,1500 degrees, and that heats up the exhaust pipes. There's a shroud around that, and what happens is around in that shroud you collect some of that heat, and it goes into the cockpit. That's how we heat planes, single engine planes like this. Low wing, high wing, it doesn't make a difference. If it's a single engine, you just take advantage of that. That way you don't have to have a separate furnace like I have in the twin. But the drawback to that is that if you develop a crack inside the exhaust manifold and that pipe, that tailpipe, that carbon monoxide can leak into that shroud that's around the exhaust pipe itself, and that can go into the cockpit. And there was one actually somewhat famous incident. Guy was flying up in Minnesota. This was maybe 2 or 3 years ago, I think, like that. He was flying and he got carbon monoxide poisoning. He didn't know it. He took off. I think it was from Minnesota, and he was talking to ATC, and all of a sudden he stopped communicating with them. And they watched his plane. He kept on flying, and then just very gently went down and landed in some forest someplace in Minnesota. They went up to the plane, and the guy was fine. He was banged up a little bit, but he was actually okay. The plane landed itself, essentially. And that's a testimony to how stable it was. I think it was a Cherokee that he was flying, how stable the aircraft is. It just basically, the engine basically ran out, and the plane landed on its own. He got taken to the hospital. He was fine afterwards. But that was a classic example of carbon monoxide poisoning. It oftentimes is much worse than that, though. Yep.
What damage was actually made?
Always.
Do you have like oxy or something?
No, carbon monoxide is I guess, it replaces I think so. Gosh, I'm not sure. We get into flight physiology.
Oxy if you wasn't able to control the aircraft.
Well, the carbon monoxide actually binds, I think, with something in the blood. And it's like the hemoglobin or something.
With like red blood cells.
Yes, it
Yeah,
does.
yeah. And so it diminishes it. So it's kind of hypoxia, but it's not the same thing. It's it basically prevents the oxygen from getting to your brain and stuff like that. And then everything just shuts down. So we do talk about hypoxia, though. Later on, we talk about carbon monoxide and hypoxia. And, there's a bunch of other ones. Yep.
Yeah, so it's like it just makes us less oxygen in the air, and the oxygen comes into your bloodstream, and that's going to transport oxygen to all the parts it needs.
Yeah.
Also, it's going to be used for pushing things in general.
Sure.
And when you have all that carbon, it's just been it's just going to be like
Yeah.
bloodstream, and everything just stops.
Yes. Yeah. You're essentially, the bottom line is your brain can't function. And this guy passed out because his brain just stopped working because he didn't have the proper oxygen to the brain, and he wound up passing out. So oftentimes it's, like it says, usually pretty tragic when you get carbon CO2 poisoning. So or carbon monoxide poisoning, that is. So they do have carbon monoxide sensors you can get. I don't know if you've ever been in a plane, like in your plane, do you see, is there like a little card on the plane someplace that says,
My instructor is headset has.
it does. Okay. Yeah.
Yeah.
Yeah. A lot of the new technology today, they can sense it through either sensors built into the headsets or the avionics. They'll have a sensor, but you can buy these little sensors and mount it on the plane. They've got chemical sensors, and all that is just a sheet of paper that changes color. So you need like a little dot. It'll change color if it senses carbon monoxide there. So let's see. We're just about done here. Yeah, bleed air heating systems. This is on page 730. That's going to be something you'll see like on a large jet, like a commercial jet. I tell you what, let's take a break and then we'll finish up the rest of this chapter, maybe dive into the instruments chapter here. So it's like, yeah, just like a quick 10-minute break and I'll take times here. Yeah, I think they actually go into that in the book. They actually talk about that's flight. We call it flight physiology. Basically, that goes into details about the different ones. And there's different types of hypoxia. Hypoxia. Here it is. It's one of them. But they actually, hypemic hypoxia, stagnant hypoxia. Hypoxia in general just means reduced oxygen.
Yeah, I find that was interesting.
Yeah,
It's interesting. And also, I have a brother who's
Asphyxiated, right?
What's that?
You're not asphyxiated.
No, I don't know. I mean, he was still breathing, so there must have been enough oxygen getting to his brain where he was all right. But when he landed, obviously he woke up. The air must have cleaned up. Actually, when he hit the ground, it probably opened up the cabin a little bit, gave him some fresh air there. So, but that was really amazing, and a lot of people were astounded that the guy walked away from it.
I have a brother who's in medical school, and so I just I just ended up learning about it, all this other stuff. Like,
it is fascinating stuff.
Yeah.
I mean, it's like my big thing, and everybody has a different chapter that they really like in aviation. A lot of people like the physics behind it. A lot of people like the systems. My big thing is always the weather.
I really like this section from the engine. I don't know why it just puts in my brain.
Mm-hmm.
I
It
just-
is. It's a lot of fun, and the more you get into aviation, the more you'll get into the other areas of it, and that's just something that you can always learn. So I'm still learning, never know it all.
So about next week, right after this class, I'm leaving and I'm heading to Kansas because I've got family and spring break for me, and I'll be in Kansas, and I will be getting back day before next week's class, and I'm just wondering if it was changing next week or it's going to be the same day.
I think we're still gonna have it on the same day. Yeah.
Same day. Is it just going to be here?
Yeah, it'll be here. Yeah, and if you can't make it, you can always watch the online.
It's okay. I might. Pretty sure we make it unless some kind of emergency happens because we go to Kansas all the time.
Sure.
And also, we're going to get back. And worst case scenario is I get back, it's midnight, and I just wake up really early.
Yeah, not a problem. And our online students, do you guys have any questions at all like that? Let me get a drink of water here.
Small things. It is. So I told them. Do everything.
All right. All right, let's dive right back into it. So Electrical systems. Can you guys think of some things that we need to have on the aircraft that are driven by the electrical system?
Lights.
Lights, yeah.
You're in
GPS, yeah.
you're in a modern system. Like a Garmin.
Yep. Avionics, yeah, absolutely.
Just the backups for everything.
Yeah, a lot of backup equipment. With the aircraft, we know there's a lot of redundancies.
Yeah.
Some, yep, radios. Yep. What's that?
Would it be like
Hydraulics can have electrical, because they'll have electrical to drive the hydraulic motors. They'll have to have something to cover the pumps, I should say. Gear systems can sometimes have, electrical systems. So the twin I have, it's driven by electrical motor.
Some of the autopilots.
Yeah, definitely. They're definitely driven by electrical.
that one sensor that's like 7500? That's the it's like the 4 numbers and it's like a code. It's like
Transponder.
yeah, transponder.
Yep. Those are all part of the basically your avionics, and all that stuff needs electrical.
Why do they just for the transponder? Why do they have codes that are just way like just armor?
Well, are you talking about when you're flying?
Yeah, like 1200 or like 7.
Yeah, that's the hijack codes and trouble codes. Yeah. So the emergency codes, I should say. So the reason why they have like in aviation, there's let's back up and share with everybody here. So there's a device inside the aircraft that's called a transponder, and essentially what the transponder does is it sends out a squawk, just like a parrot squawks. It sends out a thing, then you know where it's at. With a transponder, it's the same thing. On a transponder, you actually have 4 digits on there. They go from 0 to 7 on each digit. So a controller can say, okay, squawk in 1200. So you would actually type in 1200 or turn your dials to 1200. And then your plane's going to be sending out over the weekend. It's going to say, I'm 1200, I'm 1200. It also typically sends out an altitude. That's going to be picked up by if this right here, right, let's say this is a radar station. When the radar swings past that, it sends like what's called an interrogator signal out to the aircraft. The aircraft responds and says, I'm 1200, I'm flying at this altitude. Roughly, this is kind of a rough estimate. We get into this a little bit later. And then, but there are the transponder, since you can control that, you could actually put in what codes are in there are given by ATC, or if you have an emergency, let's say you can't use your radios. There is a code like a 7700 that you could squawk in the airplane saying you've got an emergency, or 7600 would be that you can't communicate. That just tells ATC that you've got some sort of emergency or you can't communicate with them. So they're going to divert a little bit more attention to you, because they obviously, if you've got a real emergency and you can't talk, they want to make sure that you've got a clear path to get to the nearest airport or something like that. Now, there is a hijack code. Do you know what that is?
Yes. Is it either 1500 or
7500, yeah.
And then isn't 1200 like
That's
like
just
radio?
general. Yeah, it's like if you're up flying today, like if we were to go out flying, it's a VFR day. We take off, we'd be squawking 1200. And again, what happens there is that radar beam from Madison and from Gold Field, when it hits our aircraft, our aircraft is gonna respond with that to that radar beam hitting it by setting out this code that we have on there. So we always check the code before we turn on the transponder, because what can happen in some transponders, the old style ones, they had dials for each digit of the 4 digits, and you could easily accidentally pass through 7700 or 7500 or 7600, whatever, and squawk that to Madison or Gold Field. Now, this is, most pilots know this, but if you accidentally squawk 7500 for hijack, they're not going to say anything to you. Controllers will not say anything. But the minute you land wherever you're at, you're going to be surrounded by an army of law enforcement and stuff like that, and then they're going to talk to you. So you always want to make sure that you never, when you're, like a lot of the newer digital transponders, you just type in the numbers, and it's almost impossible to type in those emergency numbers. But the old style units that had the dials for each, digit, you could pretty easily, pass through it. So you want to be careful with that. So, but when you squawk the other two emergency codes, that obviously is, they know then that they'll try to talk to you, communicate with you, and they'll do whatever they can to help you out. But the 7500, they don't say anything. They'll just, basically surround the aircraft with law enforcement.
Transponders, we can only go on certain vessels too. Is that just radios?
No, well,
Maybe like.
yeah, that's getting more into like the avionics, and that's more like ADSB, I think is what you're talking about. Those things, ADSB units will allow you to travel. Well, I should say actually transponders do allow you to penetrate class Bravo airspace within 30 miles and 100 miles. And so we get into that later on when we talk about airspace, the requirements for it. So yeah, anyway, so electrical systems, we obviously have to have electrical systems to work the all the avionics, all the stuff that we just talked about here. One of the things about the electrical systems on board an aircraft is you need some way to generate power, because the battery in the aircraft, it's just it's like a car battery, a little high-end version of a car battery. And although they do have a lot of storage capacity, you can't fly a long flight on just the battery. So you've heard of other types of things in the aircraft that might generate power for it?
Well, it's similar to cars. When cars move, they will take some of the energy from the wheel spinning to keep the battery charged. And
yes, what is that called? What's that device called? Do we know what that is?
This is the alternator.
Alternator. It's also in some of the older aircraft there were generators, but all the new aircraft they're alternators. And what an alternator does is it takes like you said, there's a accessory pack or accessory part of the engine, and the alternator is plugged into that spins along with the crankshaft of the engine. So if the engine's running, the alternator is also spinning. It's generating power and it charges up the battery. So the battery has got full power when we land. It also has power to run during the entire flight. So if you got a long 5-hour flight, your battery would only last maybe 30-40 minutes or something like that. And if it's colder out, it's going to probably last even less than that if you've got all your avionics on and everything on. So you want to have that, that alternator has got to be running. Yeah. Did you say? Okay. Yeah. So, so we have a battery switch. Let's see. Yeah, here. This is what you'll see in a lot of small aircraft engines. You'll have a battery switch right here. All that's doing when you hit that switch, that's turning the power of the battery. It's connected the battery to the main power bus for all the avionics and everything, and making it available to them. That doesn't mean all your avionics and everything's going to turn on the minute you press this. There may be another switch that you have to turn on, or you may have to turn on the individual avionics. But this alternator, that's a separate switch. And when you turn that on, that means that the alternator then, if the engine's running, can charge up the battery and provide power to the rest of the aircraft, not just the battery. So that's why we have two switches there. It's an alternator switch and battery. On twin engines, you're typically going to have two alternators, so there'd be two switches like this, or two masters, or not two masters, I should say, one battery switch, and you'll have two alternator switches, one for each engine.
The alternator thing you can hear when you first turning on the battery.
No, that would be like a turn coordinator. It's some kind of a whining sound.
Yeah.
Yeah. So, do you guys? Does your the plane that you fly, does it have like the old style turn coordinator where you can hear when you hit the master switch, you hear kind of a whining sound? Yeah. Yeah. So a lot of what you're typically hearing whenever you turn on the master switch in an aircraft is usually the turn coordinator gyro that's spinning up. So and it makes kind of a high pitch sound there. But yeah, that's what you're hearing. The alternator won't make any sound until really the engine started, and then you won't be able to hear it at all. So, all right. So that's alternator, battery there. Hydraulic systems. Yeah, we talked about that. Hydraulics. There's several different types of hydraulic systems, I should say. So you don't think about this, but brakes oftentimes, brakes can sometimes be driven by hydraulics, but they don't have a hydraulic pump. All of hydraulics are, when you think of the term hydro, what does that mean? What does hydro mean? Water. Yeah, it's a fluid. It's a fluid, right? So here you've got your reservoir. It can be oil, water, whatever. You've got a piston right here. You've got a cavity in here. This piston can move up and down. This little shaft right here can connect to flaps. It can connect to a gear linkage or something like that. But you can control which way this piston moves back and forth by either activating a pump. This could be just a hand lever that you pull back and forth, and it causes more fluid to go on this side of the cylinder right here and push that piston down and cause whatever it is this is attached to activate or deactivate or something like that. So that's a hydraulic system. Oftentimes they do have pumps. So like, especially on like larger aircraft, the commercial aircraft, they're going to have hydraulic pumps. And that's just a pilot probably could run some of the hydraulics, by themselves. So lots of, legwork, whatever. But most of the time they're driven by pumps, and that makes it easier for the pilot to control the aircraft. Whatever that may be. Gear, for instance, is going to probably large aircraft, maybe hydraulic driven. But that's going to have like some sort of pumps. And that's when you take off, you'll hear kind of a whining large, it's not like an engine as high pitch as a jet engine, but it's kind of a whining sound. Those are the hydraulic pumps filling up, maintaining the pressure in the system there. I think it's the A320s. I'm not sure. Your dad would know. I'm sure he's heard all kinds of hydraulic pumps there, but they make kind of a large, loud whining noise when they go off. So, and all they're doing is just maintaining pressure in the system, or if you change something. Indeed, some aircraft actually, their flight surfaces or control surfaces are driven by hydraulics. Most of the small aircraft, their method to change that is cables, just metal cables that run through the aircraft and pulleys and things like that. Does everybody know how hydraulics works, by the way?
Like wanting to have more pressure in there pushes.
Yeah. What you can do is like here. Let's go back to this one right here. So you can the simplest use of hydraulics is just to transfer energy from fluid in this case to a linkage right here. That's the simplest. But what you can do, if I make this a much smaller and longer little cavity right here, what I can do, or a larger, let's say to make it a larger, I'm going to actually make it easier for me to activate something. It's the same principle as the gears on a bike. If you want to go up a hill, you're going to go on a super low gear. If you want to go, downhill, you want to go really fast, you're going to go into a high gear. It works the same principles there, except that it's using fluid to get back and forth there. Okay. Let's see. Okay, and then landing gear systems. Hey Tom, how you doing? Good. I'll finish up this and then we'll have you come in. So landing gear, self-explanatory. You guys know all about it. We've talked about it. So this is a Cessna 172, and it's got fixed landing gear. We also have different types of retractable landing gear that's available out there. This is a tricycle gear aircraft. We talked about that before too. Here. Yeah.
That one was a tail dragger, and the other one was a tricycle.
Yeah, this right is a tricycle. Yeah, I'm sorry, I misspoke. Yeah.
That's okay.
That's a tricycle aircraft. The nose gear is in the front. This is a conventional or a tail wheel aircraft. A lot of people get the conventionally. Back in the day when these things were made, it was conventional landing gear. You'd think it'd be just the opposite. You'd call this conventional landing gear, but no, this is called conventional. A lot of famous aircraft have the gear in the back, so there's a lot of advantages to that. Yes.
Wouldn't you not be able to see anything until you get like?
Yeah, it's a good observation. Absolutely. And some of the larger aircraft, you have to actually taxi the aircraft when you're out taxiing. Let's say I'm taxiing in that direction right there. With the gear out, it's less like here. So with the gear out, that you've got this big cowling hanging over the front. And if you look at this right here, there's not much. If I hold it like this, you can't even see the cockpit from where you're at there. And a lot of aircraft, what you have to do is you have to taxi back and forth like this and look out the what's that? You'd use your brakes probably, yeah, or maybe they wouldn't. You know, it really depends on what the situation is. A real narrow runway, they'd probably have to use their brakes. If it's a wide runway, they'd probably just taxi back and forth there. And again, what they're doing is they're looking out this way when they're going like this, and then when the plane turns like that, they're looking out this way and they're looking straight ahead to see if there's anything in front of them. So yeah.
Wouldn't it be a bit more, I don't know, I want to be more socialistic about it.
It wouldn't help, yeah, because you're strapped into your seat. You have to have your seatbelt on. You know, once the engine's straight good.
No.
Okay, all right.
Well, it was just that once technically we get to higher speeds, we'd still be on the ground with the top back of it start to lift up a bit.
Yeah, you wouldn't taxi like that. Yeah, it's too dangerous. So it's but when you're taking off, yeah, when the plane takes off. So what Trey's talking about is when the plane takes off. So let's say I'm taking off on this runway. So this is how the plane looks when it's taking off like that. Or when it's just taxiing like that. Is that attitude. When you take off, so let's say the runway's this way, the plane takes off, what's going to happen is the guy's going to get full power. It's got a lot of torque, so it's probably going to pull to the left a lot. But what will happen is as you get more air flowing over these surfaces, the elevator gains a little more authority and the plane rises up like this. And now what happens is the pilot can now see out in front of the plane itself. That doesn't happen until you get enough speed to get some elevator authority there. Enough relative wind to get that tail to go up in the air. So, okay, let's see here. Yeah, so a couple of retractable here. This is a retractable aircraft. You can see the telltale signs of the doors there. Whereas fixed gear, usually, like if they have cowling little fairings on them like this, those are fixed gear aircraft. Pressure systems, I think we're just about done with this, guys. So pressure systems we use in aircraft, so we don't have to wear pressure masks. So I could, like in this aircraft right here, there probably has a turbocharger. A turbocharger is going to drive a pump that blows air into the cockpit and pressurizes it essentially. That allows the plane to climb it up to extremely high altitudes in 17, 18, 19,000 feet, areas where we'd actually have to have oxygen. But if we try to keep the PSI, the pressure, does anybody know what the static pressure is down here roughly in PSI? Yeah, close. Yeah, it's 14.7 is 14.7 PSI is what we're breathing right now. This is the pressure we feel. If we go up to 20,000 feet, it's a lot less pressure, and we probably pass out within about a minute or so because there's not enough pressure to get the air into our lungs. So that's why we have pressurization systems, and you can set the pressurization systems to different altitudes and things like that. So, okay, and then we also have oxygen systems. Those are oxygen systems. Basically, are oxygen feed systems to our nose or mouth or something like that. If it's to our mouth, we usually have like a little cover that we put over our a mask we put over our mouth. We can just inhale the oxygen. It's not the same as pressurization, though. Oxygen is just basically there to help get oxygen into our blood and keep us from passing out. It's not going to blow air like a pressurization system. Actually, it allows us to breathe like we are right now. If you're trying to use oxygen at 40,000 feet, your lungs just don't have the strength to draw in the oxygen. Yeah.
Yeah. So with jets, I think we already talked about this, but with those masks, they said it's not giving oxygen, it's pushing oxygen into you, right?
Yeah. You're talking about like the fighter jet. So they actually have pressurized masks. That's why their masks, when they fit on them, they're so tight because they seal off their face when they put those masks on, and then it literally blows air into their lungs. Because at the altitudes that they fly at, fighter pilots fly at, there's not enough pressure. They don't have enough strength in their lungs to draw in. So with those masks on there, that's why they're so tight. You see them strapping them on when they put their helmets on. They strap those things on there. Those are really tight against their face, and they literally blow air into their lungs when they're breathing in. Yeah. Whereas the oxygen I'm talking about here is the kind that you can just inhale or
They have to possibly leave like a red marker on.
Yeah, it did. A lot of pilots. I don't know. Did your dad ever come back? Did you ever see him with marks on his face? Yeah, yeah, and that's
Goes
from
away.
yeah. It's just one of those things that again, you're strapping it. The guys that I think had it the worst were probably the B-17 pilots in World War II because they had to really strap those things on. They had their environment was unpressurized. So the cabin they were in, it was literally open to the air. And because that mask they had to get it really tight to get oxygen into their system. So they put that on there, and then when you take these things off, you see these huge marks on it. But even today, fighter pilots have that same problem because it's a very tight seal, and it's blowing air into their system. So, all right, let's see the rest of this stuff. Yeah, they talk about the different types of oxygen feed systems. We don't need to get into that. So just know that you are required to use oxygen after above 12,500 feet after 30 minutes. So if you're at 12,600 feet, after 30 minutes, you have to have oxygen. You have to be on oxygen. Your passengers don't need to be, what's that?
What if it's pressurized?
If it's pressurized, no, you don't have to worry about it. Yeah, yeah. So if the cabin's pressurized, you just, you don't have to deal with it. But most general aviation aircraft are not pressurized. They're just, ambient air pressures, which is not going to be enough to get the oxygen in there. So again, that's a very important one. You will be tested on that. They'll ask you about, if you're at 13,000 minutes for 25 minutes, or 13,000 feet for 25 minutes, do you need oxygen? No. Beyond 30 minutes, yes, you do have to have it. Everybody in the plane has to be supplied with oxygen at 15,000. So you as the pilot have to have oxygen at 12,500 after 30 minutes. Let me get into that, into regulations and stuff like that. That's what we start with. So, all right, one last thing, and then we're going to let Tom come in here. So there are several different types of anti-ice and de-ice systems. So anti-ice, the thing you need to know about anti-ice is anti-ice helps prevent ice from forming. That would be like on a commercial jet. What they do is they sheet the leading edges of the wings itself. And that's from the bleed air from the jet engines. They produce a tremendous amount of heat, and they duct some of that heat to the leading edges of the wings. That's where your ice is going to form. That's like an anti-ice and de-ice as well. I guess it would prevent ice from forming. So another type of de-icing system would be rubber boots. They actually put those on the fronts of the wings, anywhere basically with the wind sees. They'll put those little boots on there. It's like a little rubber inflatable bladder. And it's like a series of bladders that fits on the front of that. Those actually inflate. So if you start developing ice, they'll de-ice the aircraft. They'll inflate and they'll break off the ice. So I'll just show you a couple screenshots of that. So here's a de-icing boot right here. We call it flues. That's literally it's glued onto the leading edge of the aircraft wing itself. This is uninflated right here, and then this is inflated. So there's actually a pneumatic pump that blows air into this leading edge right here. These little tubes inflate, and if there's ice on there, that ice just breaks off. It just shatters, and it frees up the leading edge anyway. Yep.
That's activated in the air. How bad would that be for the aerodynamics?
Well, yeah, icing is horrible for the aircraft. As far as are you talking about the boots? If you activated the boots, how it would affect the aircraft, or ice?
Yeah.
How it would affect the
How
aircraft?
the
Negligible. Yeah, I mean you're going to lose some speed because there's some weight to it, and there's a little bit of drag with it, but it's pretty much they're very thin. Those wing boots. They're very thin, so they almost kind of form around, but they're actually glued onto the leading edge of the wings, the wings and the tail surfaces as well. And they're also on the props too, but they're heated boots. They're not inflated boots. And I'll show you that in a second. So yeah, a pilot hits a button. If they see ice form on it, when it forms, again, if that ice is on there, this just basically inflates and it busts the ice off. It just flies off on there. So this is the weeping wing, Tegan, you were talking about before with the cirrus. See how it's got these little drips? Looks like water. That's actually some sort of glycol or anti-ice or de-icing solution. It just weeps, and then that solution kind of flows behind the wing. It flows on this right here. That would be not so much a de-ice, more of an anti-ice. It would help prevent ice from forming to begin with.
So if it would be like, say if it's a ice already, prevent stuffing it out.
Yeah, that'd be the biggest concern. It probably, I mean, I know there's some pressure to it and it might melt some of the ice, but the best time to use this is before or when you're just heading into icing conditions. And you just let it weep, and obviously because you're flowing through the air, this is the leading edge of the wing that we're looking at right here. It would flow back this way. That de-icing gel is going to flow back and it's going to kind of coat the wing. So, and they work great. They work great, except in really intense icing conditions, which most of us would never fly in if we knew that we had really bad icing. So, but it does. It's there. So again, that's pressurized fluid anti-icing fluid. Whereas the boots are more of a de-icing. They literally will de-ice the wings, not the entire wings, just the leading edge of it. That's an important point. You may have a bunch of ice that's built up behind the boots itself, but that won't break off. That most likely, in some cases, it'll shut off on its own. But most of the time, that you're going to have some ice on there. But the leading edges are what we're really concerned about because we don't want to spoil that airflow as it hits the aircraft or the leading edge of the wing. We don't want it to start creating disturbances in the wing or the airflow. So this is a prop right here. This is called a heated prop. There's just a coil that runs through here. It looks like a de-icing boot. It's not. This just heats up and it winds up heating up the whole prop itself, or at least around this area right here. And that's going to be enough to sling off any ice that forms in the prop itself. Now on a twin engine, if you've got a twin engine aircraft, you've got an engine here and an engine here. You've got two props that are hanging out here and here. When you de-ice those, you're going to hear some banging on the side of the fuselage there because the ice is slinging off there, and it makes a lot of noise. Especially if you're in moderate ice, it's going to make some noise there. So much so they usually have like metal plates or some sort of protection on the fuselage because that ice when it comes off it can really damage the fuselage itself. Okay, we're done. I'm going to pass this on. We've got Tom Cunningham is going to come in here. He's going to talk a little bit about aviation mechanics. So hold on a second, guys. We're not done yet. Let me get Tom in here and I'll have him.
Stuff you should do.
Good morning. This is Tom Cunningham. He's hopefully retiring here soon and spending some time with his grandkids. But he's had his business. Well, I'll let you actually kind of go through it.
Yeah, I've been in business for 27 years. I've been in AP and IA for close to 50. For a long time. And I'm looking forward to retiring. Joe had mentioned that maybe one or two of you fellows might have some interest in aviation maintenance. Is there anybody in here? Maybe. I've got a sheet here that gives the mechanic certain salary, present salary.
You might want to read some of those out. I think it might be surprising.
You bet. And on the back of the sheet, there are two places in the state of Wisconsin that have a facility it's an accredited school to get your A&P.
It's got a camera there.
Oh, I'm sorry.
Oh, that's right. Just want them to be able to see you there. So
Yeah.
Yeah.
Do you have any interest in possibly doing something like that? Not really? Possibly. Engineering, yeah. There's plenty of accredited schools for that as well. I don't know, I guess I'll have, if you've got any questions at all about what you might be on your mind. Anything at all?
So why are some of these like hybrid? Like,
The highlighted ones are the higher salaries. Wisconsin is the third highest in the country.
yeah, but like you also have Minnesota, Iowa, Illinois, and Michigan.
Yeah, she just highlighted a few of the states
Like that's like pretty near.
Nearby.
in close proximity to us, I guess.
So
I'm sorry, go ahead.
what would your like day-to-day consist of?
It depends on where you work. If you do opt for the airlines, then they have a specific criteria for you day to day. If you work for general aviation, you'd be doing everything from oil changes to engine removals, to inspections to diagnosing problems. It's a wide variety. In the airlines, you get paid. The pay is excellent. We are looking for licensed mechanics. So the pay is good. The locations may not be quite as good if you'd have to be at. But that's all up to you. Every industry in the aviation is looking for individual. There's a big shortage. It's about 11% at present.
So like what's their estimate if we have like shortage?
The estimated pay, the airlines, the estimated pay would be somewhere around 35 per hour. Depending on where you're living, where you're located. And general aviation is a little less than that.
That's 2 years of school, right? And then
Right.
it's an apprenticeship.
Either that or through, like he said, through an apprenticeship where you would work under somebody such as me for a period of 2 years and document 40 hours a week. Then you could go for your oral and practical and written just by going to, there's probably places in Milwaukee for that. The FA physical would have that as well.
What's your favorite plane you've worked on?
Favorite one? That's a good question.
There's a favorite.
I guess I'm partial to Beechcraft. Because that's what I started on.
Is there any particular reason, just out of curiosity, just because it built so well?
The quality of the workmanship on the Beechcraft, and most of what I worked on when I first started was the Barons, which is a twin engine, medium duty aircraft. There's 6 passengers, 5 passengers. Yeah, I always enjoyed working on them.
It's the somebody told me it's the Beach is like the Mercedes aircraft.
It is, yeah.
The Pipers and Cessnas would be like the Fords and Chevys.
Yeah.
That is true.
Yeah, the Beechcraft would be what we always call it as a Cadillac.
Cadillac.
Yeah. Mhm. The ease of maintenance, quality of the maintenance, quality of the construction was quite a bit higher than Cessna or Piper. But I did work on most of them. So
And you started Tom up in Appleton.
I started in Appleton. I worked there for 13 years for a company called Max Air, which ran a charter service. And then from there, I came down actually to here in Reedsburg. And then 11 years here and 15 over there, I think. Probably. Yeah.
Tom has done all my planes. And when I say Tom has done the planes, I'm not talking about just inspecting them. He basically just built like the 182 that I had. That was the engine was destroyed. Well, it wasn't destroyed, but it was a prop strike.
Right.
Tom essentially had to rebuild that engine and reinstall it, the engine, attach the engine, and basically get it up and running. The twin was a lot more. I don't know if you want to share with what you did.
Yeah, we, well, you had found out about it
Mhm.
after the gentleman decided he wasn't going to redo it. So we went down to Southwest Arizona in July and removed the engines and brought them back up. We had them repaired and then went down again heat of the summer and put them back on. It
Sorry, it's on.
was 114 degrees that day. So yeah, a lot of sweat.
Yeah, I still owe you from that stuff. Yeah, so you know what happened there? The gentleman that had the plane before me had Europe incident with the plane took off and something happened. He was going to gear going, and we had to land right away. And when we land a retractable gear aircraft, what happens is the props hit the surface that you're landing on. In this case, I didn't see the props afterward, but they were all curled up.
They did curl them back, yeah.
So they were basically destroyed. Anytime that happens, the engine has to be completely torn down. And in this case, what happened? Did they actually rebuild those engines, or did they?
They did repair the one. I think they rebuilt the other one. And then we did a lot of lower fuselage skin work.
Yes.
Dug a lot of sand out of there.
And so they can actually, at Tom's shop, they can actually build aluminum sections there and replace the sections. That's why when you look out at aircraft on an airfield, you'll see some aircraft. You don't know it, but they're from the 50s, 60s, 70s, and they look brand new. And that's because we're meticulous about maintaining the aircraft. And hopefully the airplane owner knows enough about it to make sure that it's maintained well. But Tom's job is to make sure that it's airworthy. He signs it off. We've got an inspection authorization. Can you talk about that a little bit? What that means?
After a 3-year period with an AMP, you can go to some training where they basically give you all the instructions for completing you have a written, a practical, and an oral. It's a complete day of really being under a hot light. But then you get your inspection authorization, which allows you to sign off annual inspections, progressive inspections, and so on, which gives you there again is another pay raise.
So you have your own plane to inspect your.
Yeah. Yep, we can do the work, do the inspection, sign it off as being airworthy for return to service. A lot of responsibility, a lot of sense of accomplishment when you're done. It is like I said, it is a big responsibility to go into that field, but it's rewarding. It is.
How many planes have you serviced over your?
Oh gosh. Well, at present, I'm doing 130 a year, 45-year period. That's what if you're.
Tom's known from basically throughout the U.S., but there's a lot of pilots that fly from. What is your furthest fly-in? Just out of curiosity.
The furthest one is down in the Abdon Park near Chicago. He comes up from there. I have 3 customers that come up from there. So.
That's what happens when you develop a good reputation. People come from all over. They are, mechanics are hard to find. There's probably some mechanics around here, maybe retired mechanics.
Yeah, there are some retired ones that will go around and do odd work, here and there. Not a lot of it, but there's unfortunately a lot of gray hair, as am I, people that are looking to retire. So it leaves a big field open for people that are interested. What's your favorite part? Watching the airplane take off successfully and not have any issues. I guess that would be my favorite part.
Have you had return customers?
Have I had return customers?
That's all we are. I think.
Yeah, that's the bulk of it. From year to year, I've got customers that I've taken care of their aircraft for 27 years.
Yeah, it's tough. Go ahead.
Have you ever missed anything?
You always do. We're all human. Nobody's infallible. Knock on wood, most of the items that I administer basically inconsequential for life safety. But it does happen.
I think to add this in there too for everybody's thinking of going into aviation maintenance. United, I think it's $75,000.
Yep.
So basically, you get that as soon as you sign up. So yeah, you can. The aviation, it's not something to sneeze at. Something to seriously look at as a long-term career. So they do very well, and they're very important.
Yep.
So, aviation, they're small.
The airline will go into the schools and they will hire you after your first year of school.
Really?
So everybody in that school, they walk in and say, you're all hired if you want to work for us.
Wow.
So is that big a shortage? So something to think about. Good wages, long term.
What's the most expensive aircraft you've worked on?
I did some minor work on a citation, which would be, I don't know, roughly 3 or 4 million. They're all expensive, unfortunately. When? Good question. The people that are buying would like it to come down tomorrow, but people that are selling want to keep it up there. So it's hard to say. It depends on the economy, I suppose.
What's the weirdest, like, just in general, weirdest thing you encountered?
Sometimes another mechanic will forget something in an aircraft. I found it's a piece of steel about so big, that's solid. I found those in aircraft that they did some root work and put that in there. Just laying in the bottom of that. A wide variety of different things. Tools, screwdrivers, wrenches. It happens. I've probably done it myself.
Sometimes
Mhm. That's why you want to take an inventory of your equipment and tools as you're done.
Sorry, I haven't learned that yet.
Yeah, I've gained quite a collection of screwdrivers over the years. And the people that left them in there would never admit to doing so.
So
They're in my box, yeah, they're mine. Flashlights. Yes. I even had one incident where I did something rather foolish. I was working on a twin engine aircraft and obviously you use a light of sorts to see. When I put the cowling on, he test flew it and he come back in. He said, something is shining out of the front of my cowling on the aircraft. I'd left the light in there and left it on. It was in the evening, so when he took off, every time the prophet comes to that point, you could get the flash of the light.
Oh, sure.
Yep.
That's
It
interesting.
was one of the more silly things I did. And if anybody tells you they've never have, they're lying to you.
One of the things you guys probably don't know about this is when you have your own shop, and Tom allows whole aircraft owners to assist in the annual inspection. So, like when I do the annual inspections, not always, but I'll come down, I'll try to open up the aircraft and just do things that I can, also things like that. But oh yeah, one of the problems that I'm sure you have, we haven't talked about it, but is because you have so many people coming in, like owners coming into your place of business, you're trying to focus on inspecting an aircraft. Somebody walks up to you, like, walk up to Tom and ask him a question. Hey, Tom, do you have a goal for this or that? Or it takes it away from you. That's one of the things I've heard. I don't know if that's very true, but it just
Oh yeah, all the time.
Yeah.
It's just something you have to get accustomed to. They are your customers, so you don't want to get angry. So
Yeah.
you just, okay.
Yeah, but it does make your job a lot more.
It does increase the time during the day to finish your project.
Yeah.
Yeah.
It's, we call it, in aviation as pilots, we call it distractions in the cockpit. And the same thing can be said for mechanics. Anybody that works in aviation, if you have a distraction, it could pull you away from something you're trying to get done. That's very important. Now, a lot of mechanics, because I think the new company that's coming out there, they don't allow people to work on their own aircraft. So you're not going to have pilots going into that shop talking to mechanics, which I'm sure you've been. So, but that's mostly for the liability reasons. Because again, let's say you're trying to do a really difficult math problem, and you're studying it, and I'm right behind you saying, hey, let's go fly right now. Let's do this. What are you going to do with it? So yeah, it just would be very difficult to focus on that problem, that task you have. And when you're inspecting aircraft or flying a plane, you want to focus on what we have. In the cockpit, we call it a sterile cockpit. I don't know if there's such a term as a sterile, maintenance shop.
It'd be nice if there was.
Yeah. So, to complicate things, my office is right above Tom shop, so it doesn't help much. Anyway, any other questions for Tom?
How many of you guys are actually active about doing your flex school? All of you?
I've been gone for the past week. So I kind of like
You are? Good for you. More young gals need to be in aviation. It's a lot more.
You guys, three.
Three.
Yeah, and one is missing. You have another one too.
I've known several ladies over the years, and most of them are less seat in the airlines.
Any other questions? Well, Tom, thank you very much for coming.
You bet.
Appreciate
Not a
it.
problem, you guys. Enjoy the rest of your day. Thank you for having me in here.
Yeah, thanks. Yeah, thank you. Yeah. Thanks again, Tom. All right, guys. So next week we dive into instruments. That's really easy. We've already talked about this. Remember the gyroscope? That's probably the most difficult thing. You guys remember I've used that before. The gyroscope is used. This right here is a directional gyro. You can see inside of it. You've got a little gyroscope that turns around there. If I can see that swinging the dial there, I turn it like that. So this gyroscope is mounted. If you can see it, there's like a little drum there. That's where the gyroscope is, right where it's moving in there. Kind of hard to see there. But it's on a gimbal mount, and that's how this directional gyroscope works. This one right here is a attitude indicator. It also has a gyroscope in it as well, and it's not spun up. That's why it's kind of moving all over the place. Next week we're going to dive into these in detail and get through it.
hose the way the air goes in.
Yeah, it probably gets sucked out of here. I should have asked him that, but I think actually, if you got a second here, let's just try to spin this up. So I've got a vacuum cleaner right here. So it's not too dissimilar than a vacuum pump on a plane. So this is an old auto attitude indicator. So the gyroscope is probably pretty old, so it may not work too well. But let's try to see if we can spin this up. It's going to take a second. I'm trying to listen to see if the gyroscope is spinning yet. Maybe speed up. You see it move there? Now I can start hearing it. You hear it? Hear that sound, that whirring sound? Okay. So that's the sound of a really old gyroscope. what you'll notice, if I bank it up like this, you see how it goes back and forth? This would be attached to the panel of the aircraft. For those of you at home, if I'm looking at this attitude indicator, if I move it down like that, that line's going to go up this or down. Yeah, because the horizon, this is going to basically mimic the horizon, that line, that white line there. And I've also turned it like left, right, whatever. It's going to do the same thing. That would represent a bank of the aircraft. So this is how an attitude indicator works. The newer style attitude indicators are usually blue on the top and black on the bottom. So it's a little bit easier to tell between sky and night. So, and obviously with all the synthetic stuff, the digital stuff, it's just a representation of the sky looks like. Anyway, we'll go into all that stuff next week. I guess that's it. So you guys are ready to go.
All right.
As always, if you guys have questions, you can email them to me. If you want to get on the simulators, let me know. Just send me an email and get you on the schedule. What's that?
Those spreads have to cost a lot.
These instruments?
Yeah, they have to cost.
Yeah, this one right here, probably if you're to buy it new, around $5,000, $5,000. Yeah.
How much is that one?
You're getting
This one right here? This right here, yeah, it's junk now. It doesn't work anymore. This one right here, this is probably the cheapest of all of them. It's maybe like you could probably get one of these for about $1,500, something like that. So, that's compass. I think it's an airspeed indicator, one of them, and this is a vertical speed. But we'll go into it all later on. So
It's one of those sheets that come in.
oh yeah, absolutely. Yeah, it's so one of our graduates, by the way, guys.
Yes.
He's offered $120,000. 2 years in school, and he's already offered $120,000 a year job. So and he went up to Oshkosh. So we'll at some point we'll start visiting some of these schools.
I know Fox Valley Tech has one, don't they?
Yes, Fox
They
Valley,
have that.
absolutely.
Yeah.
Dubuque probably does, right? They have a big school there.
They do. I know they have it designated.
Jordan, did you want one?
I was going to show you something.
Oh, yeah, sure.
So you know that hat I use for welding? I got it.
Yeah.
That's the new one.
Oh, yeah.
I got to show you all the.
Sweet.
How much I've used it.
Yeah, that's awesome.
Yeah.
People see it, huh?
Yeah.
We'll see you later. Yeah, take care, Trey.
So I should say it's gone through a lot of oxyacetylene welding, the flame welding. It's gone